Welcome to our deep dive into the microscopic world of the ocean, where some of Earth's oldest creatures, prokaryotes, are making waves in the face of climate change. These tiny organisms, invisible to the human eye, play a crucial role in our oceans, comprising about 30% of marine life. But new research suggests that these ancient beings could soon dominate marine ecosystems, and that could spell trouble for all of us. So what exactly are prokaryotes? These single-celled organisms, including bacteria and archaea, are thought to be the oldest forms of life on Earth. They thrive in environments ranging from the deepest oceans to the highest mountains. Despite their minuscule size, their sheer abundance is staggering. There are about 2 tons of marine prokaryotes for every human on the planet. Prokaryotes are vital to the ocean's food chain, supporting the nutrient needs of fish that humans consume. They also contribute significantly to the carbon cycle, producing about 20 billion tons of carbon annually, just in the top 200 meters of the ocean. But this massive carbon output is usually balanced by phytoplankton, which absorb carbon dioxide through photosynthesis, helping to limit global warming. However, climate change is altering this delicate balance. Our recent research indicates that prokaryotes are more resilient to warming oceans compared to other marine organisms. While their biomass might decline slightly with each degree of warming, it's far less than the decline predicted for larger plankton, fish, and mammals. This means that as oceans warm, prokaryotes could start to dominate marine ecosystems. This shift could have serious consequences. If prokaryotes begin to outcompete other marine life for nutrients and energy, it could reduce the availability of fish, a vital food source for billions of people worldwide. Additionally, as prokaryotes produce more carbon, the ocean's ability to absorb human emissions could decrease, making it harder to combat climate change. Our models predict that for every degree of ocean warming, prokaryotes in the top 200 meters of the ocean will produce an additional 800 million tons of carbon per year. To put that in perspective, that's equivalent to the current carbon emissions of the entire European Union. This increase in carbon production could significantly impact efforts to achieve global net zero emissions. But the potential problems don't stop there. Current projections for global fish stock declines under climate change might be underestimating the impact, because they often don't account for how warming oceans will favor prokaryotes over other marine life. If these microscopic organisms take over, the already concerning predictions for fish populations could become even worse. This is particularly troubling when you consider that fish are a major source of protein for around 3 billion people worldwide. A decline in fish stocks could lead to widespread food insecurity, particularly in regions that rely heavily on the ocean for sustenance. The ripple effects could be devastating, affecting not just food supply, but also economies and livelihoods. So what needs to happen now? Our research is just the beginning of understanding how marine prokaryotes will respond to climate change. While we've made some important discoveries, significant uncertainties remain. For example, our models are based on existing observations, and the rapidly changing conditions in our oceans may lead to outcomes we haven't yet predicted. We also need to understand how quickly prokaryotes can adapt and evolve. Existing research shows that bacteria can develop new survival traits in just a few weeks. If prokaryotes adapt faster than we anticipate, their dominance in marine ecosystems could happen even sooner, with potentially catastrophic consequences for global carbon cycles and marine food webs. Clearly, more research is needed. Scientists must continue to improve their understanding of prokaryotes and how they may be affected by a warming planet. By doing so, we can better predict the future of our oceans and develop strategies to mitigate the impacts of these ancient, tiny creatures on the world's ecosystems and food supplies. The rise of prokaryotes in response to climate change could have far-reaching effects on marine life, carbon emissions, and global food security. As we continue to explore the complexities of our changing oceans, it's crucial that we pay close attention to these microscopic powerhouses and the profound influence they may have on the future of our planet. Thank you for joining us, and stay tuned for more insights into the world of science and the environment.